Many locomotives used on the Union Pacific Railroad are supplied by the Electromotive Division of General Motors, more commonly called EMD. Although EMD has developed an AC traction motor locomotive, our main fleet still uses a brush armature type DC traction motor. Reliability of these motors has increased over the years, however they still need constant attention to head off major problems. Your job as a locomotive maintenance electrician is directly linked to the reliability of our fleet. Much of the information in this video you already know. However, you should be aware of the unusual that could cause problems later. To help you in this task, LMI 6302 has been developed and should be used as a guide in your work. Whenever a locomotive is shopped for a scheduled maintenance or troubleshooting a traction motor for ground relay or any related problem, the following instruction criteria can be used as a guide. Remember, review and follow safety requirements. Cover locomotive movements that may take place in your area, especially on the track that you're working on. Remove the top and bottom inspection covers of the motor. Examine the cover gaskets for wear, hardening, or damage. A defective cover should be replaced. Examine top cover locking clamps for damage or being extremely loose. Repair or replace as necessary. Check the keyholes on the cover for excessive wear and replace that if necessary. Also, examine the top cover support latching pins and locking pins to the motor frame for wear. Again, replace these if necessary. Inspect through the top and the bottom inspection cover openings. Check for chipped or broken brushes. If found, inspect for raised bar plus the separation of the Teflon band from the comm face at the raised bar location. Inspect for raised or missing mica from the commutator. Now check to see if the shunts are fraying on the brushes. Fraying next to the brush means the comm is out of round or possibly has a high bar. If there's fraying in the center of the shunts, it could possibly be hanging up on the brush holder fingers. Adjust or apply the shunts parallel to the brush box, not positioned at an angle. This will help eliminate the shunts being tangled up with the spring fingers on the brush holder. Also, check and replace the brushes if they are chipped, broken, or cracked, or if the brush shunts are burnt, pulled out, discolored, or frayed. Excessive wear on the face of the brush, where it's worn out the wear lines or the part number has been worn off, plus frayed shunts could indicate an out-of-round commutator. Motor should be changed out. Change the brushes if they have exceeded the recommended wear limits. If you're changing the brushes, check the brush surface that's been riding on the commutator for signs of unusual wear. Ridges or leading and trailing edge wear may indicate a need for further inspection of the commutator or brush holder adjustment. When inspecting the brush holder, lift the brush holder hammer and ensure that the brushes move freely in their pockets. Never allow the hammer to snap back down on the brush, as it may cause brush to break. Ensure that all of the brush pigtail connectors are properly secured and that the brush holder shunts will not interfere with the brush holder finger travel. The body of the brush holder should be 1/8 inch away from the commutator surface. Replace any brush holders that have loose or damaged insulators, broken or burnt spring fingers, sometimes called hammers, spring fingers with no tension in them, and burnt or badly damaged brush pockets. Examine for signs of a flashover. Some indications could be pitting at the end of the commutator bars, separation of Teflon band from the spring band area, burnt areas or paths across the spring band area, that's the Teflon band, pitting at the edge of the commutator riser, burnt or arced brush shunts, burnt springs on the brush holder, brush holder pockets burnt or pitted. If the pockets are burnt, ensure that the brushes are moving freely in the pockets. Burn insulators on the brush holders. Burn insulation on the jumper cables between the brush holders and the interpole coils. If the motor has light flashover with no apparent damage to the motor, it should be serviceable. If flashover has been extensive, which includes most of the items we've listed, then the motor should be changed out. Check for contamination inside the motor. Look for oil, excessive dirt, and other items that should not be there. Motors that cannot be cleaned with dry wiping cloth should be changed out. Brushes that have come in contact with oil should not be used. Determine the source of the oil or dirt. Look for cracks in the air duct, cracks in the duct boot, or loose or missing covers, and correct the defects. Check around the commutator in-bearing cap inside the motor for excessive oil or grease flow. This is an early sign of bearing distress, and evidenced by these pictures, could possibly cause a failure. Check for contamination of this area with excessive copper dust. This indicates a commutator problem. It also indicates excessive wear and possible damage. Inspect for overheated interpole coils and armature. Watch for ballooned insulation on the interpole coils. Replace the cover on the top and the bottom of the motor. Reapply the covers and ensuring that the gaskets are still intact to the covers. Replace as needed. When applying the bottom bolt-on covers, be sure to use a 3/4 inch long bolt. Many of the bolts we use now are too long and cause damage by stripping out the threads. Adjust or replace the covers if loose after latching or bolting them back on. Covers need to be as tight as possible to prevent loss of the cooling airflow. If the top cover latch does not tighten the cover properly and it's not cracked, remove the cover, put it in a vise, and bend the latching arm away from the cover 1/2 to 1 inch. If it's cracked, replace it. Inspect the traction motor and car body cables. Watch for traction motor boots that are cracked due to the overheating of the defective clasp connections. Boots should not be hard when squeezed. Check to assure that the boots are assembled properly. They should be slid all the way up into the umbrella boot. Make sure that the car body cable clamps are tight. On the motor, ensure that the leads are clamped tightly to the motor and that the leads are not cut or damaged. Make sure that the ground strap is connected to the motor and the underframe and not broken. Check the air duct boot for cracks or damage and have it replaced if needed. Look through the openings in the frame at the pinion end. Inspect for loose or overheated interpole coils and armature. Watch for ballooned insulation on the interpole coils. Watch for solder melted off the wire band of the armature at the pinion end. And finally, check for loose shims under the coil pieces. This could indicate a loose coil. As a professional electrician, the pride you take in your work reflects directly on you. With your help, Union Pacific will maintain its image as a railroad of quality. Please, work safely and take care.